Welcome back. This is factoring. I will be discussing general trinomial, factoring polynomials, and it is general trinomials. That means that it is not a perfect square trinomial, but we are going to see if we can find something to do with it. We can find some pattern anyway, despite that we can see that there is no such general. There is no such general pattern, but we'll see. Let's start with this example. P squared plus 5p plus 6. What you can do when you have this type of trinomials, I mean the first term is always 1, the constant coefficient is always 1. Then what you can do is look at the last term, always like that, always the last term, that the constant coefficient of the last term. For this example, we have 6, and then we need to find the factors of 6. We have 6 times 1, then we have 3 times 2. And then what you can see is add or subtract these factors. We have 6 plus 1, then we have 7, and then we have 3 plus 2, then we have 5. That means if we can find 5, which is the second term, then that means our factor is p, and then it's also p because it's square, and then you can put the factors of 6. We have the 3 and we have the 2. Because it is positive 6, then both of them are positive. It can happen that both of them are negative, but you should have this way. If I can use just a second example. So that means both of them are positive. Because this one negative. Sorry, because 6 can have a factors negative 3 and negative 2. And if we add them, that is negative 5. So the factor of this is p minus 3 and p minus 2. Let's take a look of some examples. Example number 3. V squared plus 4v minus 21. As you can see that the constant coefficient of the first term is 1 again. Then we can just look at the last term. We have 21 there, negative 21. Then we have negative 7 and 3, or negative 3 and 7. As you can see, if I will add negative 7 and 3, then I will get negative 4. And if I will add negative 3 and 7, then I have 4, which is the constant coefficient of the second term. That is my goal. I would like to find the constant coefficient of my second term. If I found it, then I will just put the first term in the 2 locations in the parentheses, and then we have this one that suits as we checked. Then we have negative 3 and 7. Try to multiply that, and then we hope that you will get the same answer. Let's see if we can find number 4. We have 2q raised to the power of 3 minus 6q squared minus 36q. As you can see, before doing something, you should ask yourself the easiest, is there a common factor? If there is, then you need to put it outside the parentheses, like 2. Because 36, there is 2 there, 6, there is 2, 2, there is 2. And then we have q everywhere, so that is q also. And the rest will be q squared, or the power of 2, raised to the power of 2, and then we have negative 3q, and then we have negative 18, that one. So negative 18, as we can see here, negative 18 can be negative 6 and 3, and negative 18 can also negative 3 and 6. It can also negative 9 and 2, can be also negative 2 and 9. So if we will add this one, we have negative 6 and 3, then we have negative 3. We already have ours. This one is positive 3. No. This one is negative 7. No. This one is negative and a positive 7. I hope I said negative 7, not positive 7. Sorry if I said positive. It is negative 7. Okay, then we are ready. I will put it here. 2q. We have 2 parentheses. We have q first there. We have q. And then we have negative 6, as we said. And we have positive 3. Yeah, and I hope you learned something. But next, in my next video, I will be discussing if the first, for example, v squared. Zeta squared minus 5 zeta minus 6. The first term is no longer 1. The numerical coefficient or the constant coefficient is no longer 1. For example, this example is number 5, we say. And we have 6 as the numerical coefficient of the first term. Then we will deal with another strategy. See you in my next video.